Hey, what's up guys? My name is the Cherno and welcome back to my C++ series. So today we're going to be taking a look at conditionals. In other words, if statements. If else, if, everything. Now I know that for a lot of you, you might think that you already know everything there is to know about if statements and else statements and all of that kind of branching behavior in C++, but I do encourage you to still watch the video because you might learn something new. I'm actually going to go a little bit deeper as to how it works in C++, so it's worth hanging around. Right, so what do I mean by conditions or if statements or branching? What is all of this? Basically, there are certain times when we write our programs that we want to evaluate a certain condition and then decide what code we want to execute as a result of that evaluation. So for example, let's say we have a variable called x and it's equal to 5. We want to be able to write code that does something specific if that value is equal to 5. That's essentially what a condition is. The condition is x equal to 5? And then based on that, we can branch to the appropriate branch of code. So there's actually two things that happen when we write an if statement and when we run that code. There's the evaluation of the actual condition, and then there's the branch depending on that evaluation. So in other words, if our condition evaluates as true, we need to jump to a certain part of our source code. If the evaluation is false, we need to jump to another part of our source code. And of course I'm saying source code, but in a running application, it really means machine instructions. So in other words, we branch to one section of our machine code, our CPU instructions, or we branch to another section of our CPU instructions. Now when we start an application, that entire application, along with all of its modules, gets loaded into memory. So basically all of those instructions that make up our program are now stored in memory. And when we have a condition that results in a branch, we're basically telling the computer, hey, jump to this part of our memory and start executing our instructions from there. Because of all that jumping around memory and branching, this is actually a little bit more complicated than it might seem, and there are quite a few things here that are worth exploring. For example, the fact that we actually have to check a condition and then jump to a different portion of our memory and start executing instructions from there actually means that if statements and branches in general do carry a little bit of overhead. And if you're trying to write very fast code, you might decide not to use if statements at all. In fact, a lot of optimized code will specifically avoid branching, avoid if statements, because by doing so, it's going to slow the program down. Eventually in this series, we are going to be taking a look at some examples of optimization by doing things like removing branches, but that's just way too early right now. I mean, I've got some huge plans for this series, so you're going to want to stay tuned. Anyway, without complicating this too much, remember, a condition, we check a condition, that's our if statement. If something is true, then we want to jump or execute a certain bunch of code. That's basically all there is to it. So, example time. I've got this very basic application that we've been using for like the last few episodes or so. I'm going to add a very basic if statement here. So let's have that x example. Let's have int x equals 5, and then let's say, hey, I only want to print hello world if x is actually equal to 5. So what I can do to make that happen is just type in if, and then the condition that I want. Now, in order for us to actually facilitate that condition, in order for us to actually check to see is x equal to 5, we actually have to perform something called a comparison. In other words, this is something where we compare one value to another, and that actually is a type of Boolean statement. So in other words, it's a type of true or false statement. X will either be 5 or it won't be, so we get true or false. Now, if we wanted to store a Boolean statement, we know that we can use the bool data type. So I can type in something like bool comparison result equals x5. Now, this operator over here, this double equal sign, is called an equality operator. It's basically going to check to see if x is equal to 5. If it is equal to 5, the result of this comparison will return true. However, if x is not 5, we will get false. So once this line of code gets executed, comparison result will be either true or false, depending on that value of x. Now, the reason that this operator works the way that it does is because it's been overloaded in the C standard library. So in other words, someone has written a function that says, I'm going to accept 2 integers, and then I'm going to check the memory of those 2 integers to make sure that they are equal. And if they are, I'm going to return true. That's really all there is to it. All of these operators that you see in C and C++, they're not like magic or anything. They've been implemented in a certain way in that standard library. In the case of something like an integer, in fact, in most primitive data structures, really all you're doing when you check to see if 2 integers, for example, are equal, is you're basically grabbing their 4 bytes of memory that they take up and just comparing each byte. Each bit of that memory has to be equal to that other variable in order for this integer to be equal. So finally, we can use that comparison result over here inside our if statement to say that if comparison result is true. Now there's two ways we could write this. We could write if comparison result equals true. However, that's not necessary, because if we just put if comparison result, if we just write if comparison result, that's going to give us the same effect as if we write true. So in other words, if comparison result isn't true, then this if statement will not run. We then need to specify some kind of body for this if statement. So in other words, where do we branch to? What happens? What code do you want me to run if that condition is true? So we can create a body here and put in that log function. And there you go, we've now created a branch. So if comparison result is true, we're going to print hello world to the console, otherwise we're not going to. Now there are quite a few interesting things we can actually talk about, even with this little code that we've written, because there's just so much that's going on here. So let's just kind of run this program first, see what happens, and we'll kind of walk through it line by line. So if I hit F5 right now to run my program, you can see that I do get that hello world. However, if I change X to be something like 6 and I hit F5, nothing's actually going to be printed. If we put a breakpoint here, now I covered breakpoints and debugging in my previous video, so if you haven't checked that out, you're going to want to check that out. There'll be like a little thing on the screen or something. Link will also be in the description. We're going to be using a lot of techniques from that video in this video, so you're going to want to check that out. I'm going to hit F5 now with my breakpoint set. Let's just close this memory view here. And then I'm going to hit F10. We're going to see that X is in fact equal to 6, where of course comparing it to see is X 5. Of course it's not 5, so if I hit F10, comparison result will be set to false. And finally, if I hit F10 over here on this if statement, it will evaluate that if statement, and you can see it jumps right to this cin.get. So it never crossed this line of code. This line of code was never called because we've basically said, hey, only log hello world if comparison result is true. If we want to take a look deeper into the behind the scenes of what's actually happening here, what CPU instructions we're running, we could compile this to assembly and inspect the output of assembly. However, there's actually one more thing we could do as part of debugging, and that is view the disassembly of this current running code. So if we hit F5 to run our program with a breakpoint set, what I can do is right click here. This is once my application is paused, right? I can right click here and select go to disassembly. And then you can see I jump into this view where we have both our source code and then the associated assembly instruction that is that source code. So in other words, our compiler has compiled this source code into this line and this source code into all of these instructions. And we can actually step through this assembly line by line and even take a look at what the registers in our CPU actually contain. So it's pretty cool. This disassembly view is actually amazingly useful when you're trying to debug either source code that you don't have access to, so in other words, you have to resort to actually debugging CPU instructions. That's an absolute nightmare, by the way. Try and avoid that as much as you can. But also it's really useful to quickly see what code the compiler has actually generated instead of setting up that whole outputting to a file stuff that I covered in my How the C++ Compiler Works video. Instead of setting all that up, we can just kind of look at the disassembly view. And so back here, you can see that the first thing that's happening here, now I'm not gonna just spend half an hour now teaching you guys assembly. I do intend to make some videos on that in the future. I think if you guys want that, you can leave a comment below, because I get asked this a lot. But basically, I'm not going to spend a bunch of time now explaining how everything works. I'm just going to kind of gloss over this. So if you are interested and you want to know more, you can either Google it or you can drop a comment below and I'll try and make a video sometime soon in the future. But if we look at this code, you can see that what's happening here is we're actually loading a register with a certain value. This move instruction, mov basically just means move. We're moving the value 6 into this register, right? So you can think of this as we're setting that X variable to be 6. And if we hit F10, we'll get to the next instruction. Now, this is our actual Boolean statement, right? So what we're doing is we're actually loading 5 into that same register. Now this is interesting because the compiler has decided to do some pretty fancy things with our code. So if we keep reading this, the next instruction is going to be a JNE, which means jump not equals. So in other words, if this comparison fails, right now, this comparison, all it's really doing is comparing those two values, 5 and 6. If they're not equal, we're going to be jumping to this memory address. Now the memory address is actually this value here, 01B59B7, right? So if we just look at the end of that, really, 9B7, you can see that it's actually this line of code. So if these are not equal, we're going to jump to this line of code. Now when we know that it's not equal, so if I hit F10, you can see that our instruction pointer, so this yellow arrow, is actually what our CPU is executing. it jumps to that memory address to execute the next instruction, which is going to be moving a certain value, in this case 0, into this register. Now, this register, which is EBP, which is an actual register minus a certain offset here, we're going to be loading the value 0 into it. Now, this comes back to what Booleans are. When I talked about variables in C++ in that video, which you're also going to want to check out if you haven't, I talked about the fact that a Boolean is essentially a 1-byte data type. And like any data type, of course, there's no concept of true or false in C++. So how do Booleans even work? Basically, if the value is 0, then it's false. And if the value is anything but 0, the value is true. Again, we're just dealing with numbers. Computers deal with numbers here. But because we've got that huge 1 byte of addressable memory, and if we create a Boolean, it is actually going to occupy 1 byte of memory, we don't necessarily have to make sure that that 1 bit is set to 1. So like, it's really, if anything there is not 0, then it's going to be true, right? If we were just dealing with 1 bit, of course, we'd only have 2 possible values, 0 and 1. And if it was 0, it would be false. If it's 1, it would be true. However, since we have such a big range of numbers, we can safely say that even if the value is, say, 100, that's also going to be true, of course, and just 0 will actually be false. So that being said, what's actually happening here is we're loading 0 into that register. So we're assigning 0 into that Boolean. So false is 0. Get that into your head. False is 0 and true is usually 1. If we explicitly load a value in, it will probably be 1. However, there's nothing really that actually forces us to be setting 1. It could be anything, right? So false is actually 0. True is actually 1 asterisk. So this move instruction is loading 0 into that memory, which is equal to false, right? So it's basically setting that Boolean to false because this comparison failed. If we keep going here, there's going to be some other kind of code that we don't really care about. And finally, we get to the if instruction. So what we're doing in the if instruction is, again, we're just loading certain values into the EAX register. We're testing to see if that EAX register actually passes our conditions. Now this test instruction is going to basically perform a bitwise AND operation on those two registers. I don't want to get too in depth into this, but basically if this test operation succeeds, you can see that we're going to jump equal. So in other words, if that test operation is true, we're actually going to be jumping to the memory that is 90F, which is actually this line of code here. So we skip past that actual logging. If this is not the case, right, so we don't jump equal, so the fact that it says, it's not a regular jump instruction, right, which is JMP, it's jump equal, so it's a conditional jump statement. So in other words, if this fails, then we're just going to advance to the next line of code, which is here, right, the next CPU instruction. Which is actually going to do all of this. However, we know that this test is going to succeed because comparison result is false. And so if we hit F10, you can see we actually do jump over here and we continue running our program kind of as normal. All right, so that's kind of a deeper look at what actually happens behind the scenes with an if statement. Now, keep in mind, I am compiling this and running this in debug mode, which means that it's not going to optimize our code at all. So if we look back to our code, we can see that all of this can actually really be simplified. The compiler knows that this variable x is hard-coded to 6. We're doing a comparison to 5. It can actually do that itself. We don't have to do that comparison at runtime. We can actually see, is 6 equal to 5? We can do that at compile time. And so something called constant folding will happen. So it'll turn this all into a constant variable because it is a constant variable. All of it's known at compile time. And then it's going to actually get rid of this if comparison result if statement altogether and leave us with just stdcn.get. Like, it'll just remove basically lines 6 through 11 because they're never going to run. So why compile them? Why do that? Why do that conditional check at runtime? That's just going to take extra time and we clearly don't need it. Keep in mind, if you're trying to play around with this and see how things work by looking at the disassembly, just make sure you're in debug mode and make sure you've got optimization turned off as much as possible, because if you don't, the compiler will perform some of its magic and you'll just get wrecked. All right, so back to this. We know that this comparison result it's a Boolean, right? And a Boolean is really just basically an integer, right? It's going to be 0 for false and anything else such as 1 for true. So what this if statement is actually doing is it's checking to say, hey, is this number 0, right? And if it is 0, then it's not going to perform that if statement. However, if it is anything other than 0, such as 1, it is going to jump into that if statement. That's kind of why this whole thing works and we don't have to do something like equals equals true, because we don't need to be checking, hey, is it equal to 1 or is it equal to true or anything like that. We can just kind of say, hey, is this value not 0? That's really what this is doing. It's saying, take a look at the memory behind comparison result, right? What is comparison result? Is it 0? If it's not 0, then execute this code. If it is 0, do not. That is what an if statement boils down to. So for example, if I just write if 1 over here and run my code, it's going to compile just fine, and you're going to see that hello world does actually get printed, right? And if I type if 0, then it's not. Pretty simple. We already know that it works that way. With this comparison result, of course, we don't need to store this in a variable. The reason I did this was I just wanted to show you guys that this condition is actually a Boolean type. You can just write if x equals 5 over here, and that will simplify your code quite a bit. If our if statement is just one line of code as well, we don't need to provide curly brackets for a body. We can just write something like this and it will be fine. You can even format this. Some people format this to be on one line. I personally do not do that. It's a little bit annoying when it's on one line because if you're trying to debug, so for example, if I put a breakpoint here, you're going to see that it's actually going to hit this line and I have no idea if it's actually doing the comparison or if it's actually logging the function. If I hit F10, it's just going to go past. I have no idea what's going on. Whereas if I do separate it out into two lines like this, I can actually check. You can see that if I hit F10, look, it's not going to that line. So clearly that line has not been executed. Nice and simple. Because Booleans are just numeric values, and because this if statement is basically just checking something numerically, you can do some pretty interesting things with if statements. For example, I can just write if x, right? And then if I run that code, it's going to basically be, again, evaluating, hey, is x 0 or is it not? And of course, x is 6. So if I hit F10, we're going to jump into that log function and actually perform that log. It's also very common to use this trick with pointers. So if we want to check to see if a pointer is null of course is 0, we can just basically put that pointer in an if statement condition like this and see if it's null or not. So in other words, if I had a pointer, for example, const char pointer equals hello, I could just say if pointer log pointer. And if I run this code, you can see pointer is actually set to something, it's not null, and because of that, we're going to be able to print that to the console over here, okay? And if pointer was equal to null, so it could be 0 or null pointer or whatever you want to type, you can see that this code will not run, okay? So basically, instead of writing if pointer does not equal null pointer, we can be a little bit more concise and just write if pointer. Now this is more of a matter of style as well. Some people do like to be explicit because they claim that it makes the code a little bit more readable. I personally don't mind. I usually end up writing code like this because to me it makes sense, right? If pointer is basically a valid value, hey, do this, right? Keeps the code nice and clean, and it's something that you can do in C++ that you can't really do in other languages such as Java or C#. So they're a little bit more explicit. But C++, again, it's kind of a raw language, right? So anything really goes. Now, if we want to do something else, right? So basically I'm saying here, if pointer is a valid value, right? If it's not null, then log. But what if I want to run some code that only happens if this is not the case, right? That's where an else statement comes in. So I can write else log pointer is null, right? And then if I run my program right now, you can see what's going to happen. It's going to print pointer is null, of course, because if I step through this line by line by using the debugger, pointer is going to be null or 0. It's not going to perform this and it's going to jump right to the else. Pretty cool. Now similarly, we can also use else if to keep checking for conditions. So in other words, I could check to see if pointer is equal to hello or something like that, and then maybe log pointer is hello, right? And what's going to happen is because this is an else if, it's actually only going to check this condition if this one fails, right? So the code that I've written here would theoretically never run, right? Or at least this part would never run, because if pointer was not null, then this would catch it, right? And this would not. So again, if I set my code to something like hello, and then I hit F5, what's going to happen is pointer is going to be not null, so this branch is actually going to catch that. And then if I hit F10, you can see we jump all the way over here because none of this really matters, right? Only do these things, only even check this if this first one fails. However, if I had written something like if without an else if, right? Then you can see that it is actually still going to check that, and that's going to succeed, and we actually end up printing two things to the console. So just something to keep in mind. Now, an else if statement is actually a little bit of a trick that you might not realize is actually happening to you. It's really just kind of cleverly hidden syntax in a way. So if we jump back to our code, what we'll see if I try and write this else if statement is it is actually two separate statements. It's an else and it's an if, completely separate, because check this out. That is exactly what happens, right? So basically we're saying with our else if, it's just kind of combined into one line here, right? The same way that we're kind of combining this into one line, it's kind of like if we had written this in a way, right? So again, else if, just a clever little else, and then if. So basically what we're saying is if this condition fails, then try do an if pointer equals hello. So again, it's going to only do that comparison if that else gets triggered, which will happen if this is false, and then it will run our code. So yeah, clever little trick. I remember when I found that out, it kind of blew my mind because I didn't realize it at the time. I thought else if was actually some kind of just keyword combination, but no. Else if is literally just, there is no else if keyword in C++. There's else and there's if, right? And all we're doing here is we're saying else if, right? Pretty cool. All right, so anyway, I've said pretty much all I can about the basics of if statements and conditionals and branches and jumps and all of that stuff. Hope you guys understand how this all works. So I'm pretty sure I covered like everything. If you didn't get much, don't worry, I've made this very complicated, but on the other hand, I have shown you a little bit extra than I think most tutorials on if statements probably would have. We'll be using if statements everywhere in our code. There's two real parts to programming. There's kind of mathematical programming and logical programming. At least I like to divide programming into those kind of two terms, right? There's like programming where you can actually just do like mathematical operations, and that does make up a lot. In fact, most fast code is actually written by doing like mathematical operations essentially, instead of the second part of programming, or the second kind of section of programming that I call logical programming, which is all about logic, right? So hey, if this is this, then do that, right? If this, then that. That's kind of a little bit more boring. I'm not saying that it doesn't have a place. Of course it does. It's you can't write. There is no game written. There is no real application or game written without using if statements or anything like that. I'm just saying that in the future, as we kind of learn to write better code, you'll see that a lot of the cases where you might have used an if statement, I would not, right? I would try and somehow make some kind of mathematical like calculation out of it instead of actually performing like a comparison and a branch based off that, because by doing so you can actually slow your program down quite a bit, and it's quote unquote considered kind of worse code. It might make more sense, but anyway, I'm just gonna ramble. I'm just gonna keep rambling on, so I'm gonna stop right here. If you guys enjoyed this video, please hit that like button. You can follow me on Twitter and Instagram. I suggest you do so. And if you really like this series, you can support me on Patreon. Link is in the description, patreon.com/thecherno. You can support the creation of more episodes of this series, as well as see early drafts, and even kind of, there's like a nice little group chat that we have going on Slack where we talk about stuff, life in general as well, but we try and talk about what actually goes into these episodes. And basically, you guys, you supporters, help me plan these episodes and make them as good as they are. So if you want to be part of that, you can jump in by going to patreon.com/thecherno. Other than that, guys, hope you enjoyed this episode, and I'll see you very soon. Goodbye.